Welcome back to Math 155, section 8.3. In this lecture video, let me show you what this empirical rule is. Okay, so if a data has a distribution, remember the word distribution is referring to how we're describing the data. If the distribution has this thing called the bell curve shape, we can use this thing called the empirical rule to determine the percentage of data that will lie within so many standard deviation of the mean. All right. So if it's a bell curve shape, that means the mean, the sample mean, is always going to be right here in the middle. Okay. So one standard deviation to the right and to the left, okay, that will cover 68% of the data. Okay. So 68% of data should be within one standard deviation. So here we say plus and minus is because to the right is above the mean, to the left side is below the mean. If we go two standard deviation out, okay, from the mean, that will cover 95% of your data. 95% of your data should be actually within two standard deviation. So if you go out one more standard deviation, so from here all the way to here, that should cover 99.7% of data, which is 3 standard deviation out. So as long as we can create, okay, as long as I have a bell curve shape, then I can use these percentage to help me to answer some of these questions. So suppose that an IQ score have a bell-shaped distribution, which is look just like the picture above, with a mean of 105 and a standard deviation of 15. Use an empirical rule. What percentage of the IQ score are less than 75? So first thing we gotta do is the mean. Where is the mean for the bell-shaped distribution? The mean is always going to be in the middle, and the problem tells me the mean is 105. So if I go one standard deviation to the right, that will be 105 plus my standard deviation 15, which will give me 120. Okay. If I go one standard deviation below the mean, that will be 105 minus 15, which will be 90. Okay. Now, what percentage of score are less than 75? So 75 is to the left side of the mean, so I need to keep on going left until I can hit 75. So from 90, one more standard deviation to the left, so every standard deviation is 15 at a time. Okay, so 90 minus 15 should be 75. So the question is asking how many percent is from this place to the left of it. Okay, so my 75 is actually 2 standard deviation below. So if you look up here, if you take this picture and look at this chart, so this is where the 75 is. So how much percentage is to the left of that? Okay, so this is real easy to figure out. We got a couple ways we can do this. All right. Remember the 75 is actually lined up with 95%, within 95%. So from here to here is 95%. So that means I'm looking for the outside. Well, the whole thing should be 100%. So if I take 100% minus the 95, which I'm taking away the whole middle part, that should leave me with the outside, the two outside, 5% total. But I'm only interested in knowing less than 75, which is only one-sided. Okay, so if I divide it by 2, that will give me 2.5%. So only 2.5% to the left side of my IQ score 75. Okay, so my answer got to be 2.5%. Okay, what percentage to the is less than 75 or to the left of 75, which is only 2.5%. So if you take 2.4% plus the 0.1% up here, you get 2.5 as well. Two different ways we can figure it out. All right. So let's try again, okay? So another IQ problem with a mean 101. So 101 is right here. Standard deviation is 14 at a time. What percentage of the IQ score is at least 115? At least means 115 and more. At least means 115 and more. More will be going to the right. 115 is located to the right, okay, of my mean. So if I go 101, which is the mean, plus one standard deviation to the right, then I will reach this 115 IQ score. So the question is asking at least 115. That means 115 and more. That will be everything to the right side of 115. So that's how many percent. What percentage would that be? So if I only go to the right, one standard deviation, and I'm looking for this, so this is where the 115 is, and I'm looking for all the percentage on this side. Okay. So that means there's a couple ways we can do it again, okay? Normally what we do is to say the 115, let me erase the 75. The 115 is actually one standard deviation to the right of the mean. So we think one standard deviation covers 68%, so that will be 100 minus 68. So that means that outside the one standard deviation together is 32%. So since I'm only interested in one half of it, if I divide it by 2, that will give me 16%. Okay. All right. Another way to do this is take the 13.5 that I have on the table, plus the 2.4, and plus the 0.1. And that should give me the same as the 16, I suppose. Yep. Sure does. All right, so two different ways we can calculate the percentage. So my answer is 16%. All right, let's try it again, okay? Suppose the diastolic blood pressure reading of an adult male have bell-shaped distribution with a mean of 78. So right away, 78 is right here in the middle. And a standard deviation of 8. Can't remember what HG stands for. Okay. Describe approximately where the 99.7% is located. So remember that 99.7% is actually 3 standard deviation out. Okay. So where is the 3 standard deviation? So 1 standard deviation is to the right below. We just subtract standard deviation 1 time. 2 standard deviation out, we will actually take the mean, subtract or plus 2 of these, 8. So 3 standard deviation out. So that will be my mean minus 3 times the standard deviation 8. So that will be the one on the left side. 78 plus 3 times the standard deviation 8. That will give me the right side. So what would that be? 78 minus 24 give me 54. So that blood pressure got it ranging from 54 to 78 plus 24 to 102. All right, so my choice will be here, this one in the second choice. All right, so 99.7% of that blood pressure, okay, 99.7% of a blood pressure got to be from 54 to 102. All right, let's try this one. Suppose that the grade point average of an undergraduate student at one university has a bell-shaped distribution with a mean of 2.52 GPA. So the mean is 2.52 GPA. And a standard deviation of 0.45. Use an empirical rule. What percentage of students have a grade point average that's between 1.6 to 3.42? So let's find this 1.62. 1.62 is to the left side of the mean. So if I go 1 standard deviation below which is 2.52 minus 1.62, then I'm at 0.9. Oh, I'm sorry. 2.52 minus standard deviation is only 0.45, right? Sorry about that. Then I reach 2.07. All right, let's go down again. 2 standard deviation below the mean. So that will be minus another 0.45, which will give me 1.62. So 1.62 right now is 2 standard deviation below all the way to, or 1 standard deviation above the mean. 2.52 plus 0.45 is 2.97. So if I go one more, so this is the mean, okay? This is the second standard deviation to the right of the mean. So I plus 0.45 again. So that will be 3.42, which is what that number is. So sorry, I didn't draw very pretty. So 2 standard deviation, okay, 1.62 to 3.42, each one is 2 standard deviation above and below the mean. So 2 standard deviation will be 95%. So that would be my answer. So 95% of a student has a GPA of 1.62 to 3.42. All right. So that will conclude this lecture video on what we so-called the empirical rule, and this lecture video will also conclude our entire section. Will also conclude our section 8.3. And I do appreciate y'all keep on watching these lecture videos. I know sometimes they can drag a little bit longer, but I hope you do enjoy this class. And I do truly appreciate you watching all the lecture videos. Thank you for watching.